Okay, let's talk about powers of secants and tangents now in terms of integration. And by the way, as we do this for secants and tangents, you should know the same strategy works for cosecants and cotangents. In cosecants, cotangents, you might have an extra minus sign here or there, so just be careful with those as well. Anyway, what we try to do with these guys is do a use substitution, but before we do that, we should really go ahead and find out or remember what we know about the integration of secants and tangents. So let's start with tangent. The integral of tangent, okay, in Calc 1, maybe you encountered it. They would look at it as, well, that's the same as sine over cosine. If you've never seen it before, then the u substitution, let u equal cosine, will lead to the following answer. It's minus the natural log absolute of cosine plus c, or as some people like to write, it's equal to natural log absolute of secant plus c, because that negative in front of the logarithm can go in as a power of -1, which flips cosine over, etc. So you might want to inspect that. Another one, the integral of secant, may or may not have been taught to you, is the same. The way they come about that guy, and I'll let you fill in the blanks here because I'm thinking you should know some of this, is they multiply top and bottom by secant and plus tangent. And ultimately what you get is the natural log absolute of secant plus tangent plus c. So the integral of secant is the natural log of that guy. Really? Yeah. So some of you have seen it, some of you might not have seen that in your Calc 1 experience. So write those ones down as stuff you don't want to redo again and again. You want to try to remember it when you run into these bigger problems we see and it says integral of tangent. You're going to go, oh, well, that one is a one-liner, or the integral of secant as well. Let's go to the second powers. If we went, so for example, went to the integral of secant squared x dx, derivative of tangent is secant squared, integral of secant squared is tangent. You got it. This guy is tan x plus c. So that's one that we should know. And then finally, maybe we do the second power of tangent. Okay, well, sine squared over cos, no. You know what you do? Look at this. This is going to be, you know, we do this a lot in our class. We write it as secant squared x minus 1. And each one we can integrate because integral of secant squared is tangent, etc. So we get tan minus integral of 1 is x and plus c. So we actually have the integral of tan squared. A lot of that stuff is, there you go. So there's some cleverness involved. These guys you want to turn into one-liners. You should, of course, already know that as a one-liner. And this one's new. Put it in terms of secant. So a lot of times in this section, we just kind of mess around with this. Now check this one out. We're looking at, in our example, we've got secant to the 4th x times tan cubed x dx. Okay, you can actually do this two different ways. Okay, whenever you encounter a problem with powers of secants and tangents, you can break into two different pathways on it, and one will work, or the other will work, or both will work, or you know what, both won't work. That's the next video if they don't both work. This one, they both do. Okay, so what I mean by that is you can rewrite this guy. In this case, I'm going to peel off a secant and a tangent, okay, in anticipation of letting u equal secant. Because if u is secant, du is secant tangent, that's the derivative. And so I'm hoping to do that. What I want is everything else to be written in terms of secant so the u sub makes sense so that I can do this substitution. Okay, so if I take away one of each, then the problem would leave me, see, I'm working on this problem up here, it would leave me secant cubed and then a tangent squared. Because I took away a secant and a tangent right there, okay? And then the thing is, okay, if I'm going to use the substitution, Here is going to be, if I let u equal secant, then du is equal to secant times tangent dx. Okay, and that'll be all of that. That means I have to have everything here in terms of just secant, because I'm using let u equal secant. And can I do that? Well, secant cube is in good shape, so we have integral of secant cubed x. All right. Tangent squared's not good. I got to switch them in terms of secant. Can I? Yeah, because he's an even power. I can use Pythagoras on him. See, I took away one of them. I took away a tangent. He drops to an even power, and he can switch over to secant. So the book will say, if you've got an odd power of tangent, you can do a substitution, okay? Possibly, all right? So tangent squared can be written as secant squared x minus 1 times secant times tangent dx. And with this substitution here, okay, our problem changes into integral of u, not secant, but u now, cubed, and then u squared minus 1, and then all of this, like I said, is du. And the rest is gravy, right? We distribute and integrate and finish the problem. So we have the integral u to the 5th minus u cubed du is equal to, let's cut to the chase. It's 1/6 u to the 6th, but u, remember, is secant. So secant to the 6th x minus 1/4 u to the 4th. How about secant to the 4th x? And then plus c, because folks, we're done. Okay. All right. I usually pause there, but you can pause the video. Now, if we go up here and, okay, this first time we did that substitution. Now we're going to do a different one. We're going to do one that says, hey, but how about we do this by peeling off a secant squared? Is that even possible? Because if you peel off a secant squared, what you're anticipating is letting u equal tangent, not secant this time, but tangent. And then du is secant squared x dx. And we hope to get everything over here in terms of tangent, okay? What do we have if we take off 2 secants? Well, we still have a couple more secants, secant squared. We went from 4 to 2 to 2 and 2, and then we have a tangent cubed left over, okay? So can we write everything in terms of tangent? Let me look. Yeah, I've got a secant squared. The book would say, if you've got an even power of secant, you can peel off 2 and change it into tangent, and you can do u sub, and that's what we're doing. So secant squared can be changed into tangent squared x plus 1. There's still a tan cubed x out there times secant squared x dx. And this is where we kick it into gear. And what we have is, with this u substitution right here, every tangent turns into u. So we have an integral u squared plus 1 u cubed, and then the secant squared dx is just du. And again, you distribute, you get integral u to the 5th plus u to the 3rd du, and we're off to the races. We've got, what we have is integrating that, we have 1/6 u to the 6th, but this time u is tangent. Tangent to the 6th x plus 1/4 tangent to the 4th plus c. And I did it 2 different ways, so can you. Pick one on a test, of course, pick your favorite. And you look at these 2 answers, and they're numerically or trigonometrically identical, equivalent, I should say. And your job is to use identities to make one match the other. I'm just kidding, you don't have to do that part. But there you go. I mean, this one is actually doing it 2 ways. You know, it takes a little thinking, but again, if you've got, what was it again? If you've got an odd power of tangent, you can do it one way, you can use u equals secant, or if you've got an even power of secant, you can let u equal tangent and you can get the job done. The next video says, what if you don't have either one of them? Let's go find out. All right.